let's solve this down question. It said a solid material of volume 100 cubic centimeters is heated through a temperature difference of 40 degrees Celsius. Calculate the increase in volume of the material if its linear expansivity is 2 exponential minus 6 per k. Options: option A 2.4 exponential minus 2 per cubic centimeter. Option B 1.6 times 10 raised to power minus 2 per cubic. Remember, we were asked to solve for volume. So for you to do that, we need to get a formula for linear expansivity first, which is alpha. So solution alpha is equal to L2 minus L1 all over L1 open bracket change in theta. So this is our what? Our linear expansivity. For example, if you're talking about expansion of a material, for example, if it's okay, this is we're dealing with length. But when you are talking about cubic expansivity is actually referring to volume of. So you are referring to a volume. For example, something like this, referring to what? A volume. So that is for cubic expansivity. So we're referring to a volume, not the length as linear expansivity. We're dealing with cubic expansivity now. So remember that the linear expansivity was given and the temperature as well was given. So what? Let's write all our parameters out. Let's write all our parameters out. So the first one, L1 is equal to what? 100 cubic centimeter. What else was given in this question? Change in theta. They said, where is it? Change in theta, that's the temperature difference. That's the change is equal to what now? 40 degrees Celsius. But remember that the another thing that was given here is the linear expansivity, not the cubic expansivity. So not the cubic expansivity. So for you to do this one now, what is our linear? So alpha is equal to what now? 2.0 times 10 raised to power minus 6, then per k. But that's not what you are looking for. We are looking for what? Our cubic expansivity. Now so our cubic expansivity will give me V2 minus V1 all over V1 open bracket change in what? Theta. Change in theta, close the bracket. So now let's simplify this one now. Don't forget that we're looking for what? Cubic expansivity. And this cubic expansivity here is equal to what now? 3 alpha. Remember, we're dealing with volume. 3 alpha. So if I have this one as 3 alpha, so I'll break this one down, which is this 3 times what? 2.0 raised to power minus 6, that's per k. So this one will now give me what? If I multiply this one, it will give me 6.0 times 10 raised to power minus 6 per k. Now this is our what? Our per k. This is our cubic expansivity. So we cannot go to the question and solve now, which this form, use this formula, which is remember, what are we looking for? We are looking for what? Remember, they say the solid of the material volume of this. So we are actually looking for the additional volume. The additional volume, not necessarily mean we are not looking for the total volume of that object. There is a difference between these two. So most students will confuse about this. So we are talking about the additional volume gained due to heating. Additional volume gained due to heating, not the total volume of that particular after heating. Not the total volume. For example, V1 is equal to what now? 40 cubic centimeter. Then I ask you, what is V2? V2 is just what? Is the total volume after heating. That's total volume after heating. Don't get confused. Total volume after heating. So V2, maybe after applying your heat and everything, so you cannot have it. But when you're talking about additional volume, this one is additional volume added due to heating, and this one is basically additional volume. This one is just basically changing what? V. Changing V. That's what we're talking about here. Not necessarily mean the total volume after heating. So let's go. Gamma is equal to V2 minus V1 all over V1 open bracket change open bracket change in theta. Change in theta. So now don't forget that V2 minus V1 is the same thing as what? Change in theta, which is additional volume gain due to heating. V2 minus V1 is equal to gamma, which is the cubic expansivity times V1, then open bracket or change in theta, close the bracket. All right. So now what am I looking for? I'm looking for the additional volume. So this one will not give me. Remember, this one is what? What is this one? This one is a 6, which is our cubic expansivity 0.0 times 10 raised to the power minus 6 times, what is our V1? That's a times 100 times what? Change the temperature is what? 40. So what would this one give me? Remember, this is what we're looking for, which is what? Change in V. Change in V. All right. So now let's multiply this. Now let's point our calculator. So we have 6. So we have 6 exponential minus 6. That's times 10 raised to the power minus 6, basically. Exponential minus 6 times 100 times 40 times 40. So this one will not give me 0.024. All right, so I can also take this one to standard form. If I take this one to standard form, which is this 2.4 times 10 raised to the power. How many times did I move? 1, 2 times 10 raised to the power minus 2. So this will now be 2.4 times 10 raised to the power minus 2, and then per cubic centimeter. And this is our final answer. And the answer in that question is option A, which is 2.4 times 10 raised to the power minus 2 per cubic centimeter. All right. Thank you. See you in my next video.